Chapter 7 of Sociology 3392, Sampling. So, why do we sample? We don't, if we're doing a survey, we don't want to ask every single person in a population. The population is aggregated elements in a study. So for example, if we're looking at individuals, the population would be that group of individuals. So maybe Americans can be your population, maybe Texas Tech students. But if we're doing a survey, we're not going to be able to, and we don't need to, ask every single person at Texas Tech. Instead, we could make a sample or a subset of a population that's used in research. Sampling element is what the population is composed of. For example, individuals would be our TTU sample, our TTU student sample. A sampling unit is an element in a sample. And then sampling, the process of selecting observations. So this is where you are choosing who you want to interview or survey out of that population. So we're going to talk a lot about different types of samples today. So why is sampling important? Well, if you're not sampling correctly, you're just not going to get an accurate look at what you're studying. So a good example of when sampling goes wrong is the 1936 presidential election. So they did a poll in Literary Digest magazine, and I believe that they got like 1 million people to answer the poll. So a very, very, very large sample that was reading the magazine. So they polled these people responded, and then they wanted to predict who was going to win the presidential election. They predicted the Republican was going to win, but they were very, very wrong, and actually the Democrat won. So what went wrong? Well, first off, they polled people that tended to be of a higher socioeconomic status than the population, than Americans in general. So they polled people that read magazines, owned cars, and had phone numbers, where in 1936, these people tended to be a little bit higher socioeconomic status, and people that are higher socioeconomic status tend to vote Republican. So again, this is an example of when sampling goes wrong, you're not going to get an accurate look at your population. Okay, so first we're going to talk about non-probability samples. So this is any technique in which samples are selected in some way not suggested by probability theory. So this is the more basic type of sampling. You're going to be using this type of sampling if you choose to, for your projects. There's times when you should use it, times when you should not use it. So we will talk a little bit about this today. Okay, your most basic sample is your convenience sample. This is basically anyone or whatever is available. It doesn't allow for control over representativeness. So you can't say from a convenience sample that your results from your study generalize to a larger population. It's really only justified if less risky methods are unavailable, and researchers must be very cautious about generalizing when this method is used. So again, this is simply asking who is available to be part of your study, but a lot of times maybe it's a little bit biased. So if your population is Texas Tech students and you're only asking people in your sociology class to take your survey, then that's going to be really biased. However, I'm not saying that this is like always horribly wrong to use. There's times when it makes sense to use a convenience sample. Okay, so here's a little depiction of what a convenience sample looks like. So here we have different demographics, African American and white, men and women. So we see here, if we're just sort of picking whoever's available, we only get a small subset of the population. So it's not representative because we actually don't have any African American men or women in the sample. So again, it's probably going to be pretty biased when you do a convenience sample, but sometimes that's sort of the best that you have. For the purposes of your project, you're probably going to be using a convenience sample, which is fine. That's what I'm expecting. We only have a month to do this, so I'm not expecting anything, any sort of crazy sampling. But just keep in mind that you're not going to be able to generalize it to a larger population. Okay, so next is purposive sample, and this is similar to a convenience sample where you're kind of asking who's available, but the units are selected by what the researcher thinks will be most useful for their research question. So they're making, the researcher has, some things that the people involved in the sample need to have, the population needs to have. So say that they want to look at, if we're doing Texas Tech students, maybe the research question is particularly interested in biology students and psychology students, for example. So here we might, make it a requirement that the person that's part of the sample is taking those courses. So again, this is good for small subsets of the population if it specifically applies to your research question. Two-group comparison, again, you want to make sure you have both biology students and psychology students in your sample to be able to compare them. And then deviant cases. So if something's, doesn't quite fit the mold of what's, most common, maybe you're going to, pick your purposive sample from that. Okay, so next is a snowball sample. This is usually done when you have a hard-to-reach population. So, maybe there's not a list or an easy way of contacting people that you are looking for. So this is used a lot with people involved in offending. So I had a mentor in graduate school who did a project on a very long-term research project on active burglars. Well, it's pretty hard to find active burglars if you don't already know someone. So he used snowball sampling. So he found an informant, which is somebody that sort of has it in on this population. So he, had a buddy that used to be an active burglar, I guess, and he was able to give access to this population. And then, the snowball keeps building. So maybe a couple of people get interviewed and the researcher says, well, if you know any more burglars, tell them that I'll give them $50 if I can do an interview with them. So they pass that information on. The snowball gets bigger and bigger and bigger. So this is often used in field research, again, with hard to reach populations and maybe topics that are a little bit more sensitive. So example, active burglars, perfect example of a snowball sample. They're going to be a little bit wary of talking about their burglaries when they're still, committing crime with just anybody. So they kind of need that informant to get it in and, build a trusting relationship with the researcher. Okay, next is a quota sample. So this is selected on pre-selected characteristics, usually done with demographics, not always. Maybe, for example, our TTU population, maybe we want a few different majors to be represented in the sample. So the sample will have the same distribution as the population. So, for example, say the population is 40% adult males, 30% adult females, and 30% children, well, then that sample will match that larger population. So just making sure that everybody is included on a specific demographic that is, or another characteristic that is that mirrors the larger population. Okay, so now we're going to talk about probability samples. So these are much more difficult to do, but they have the benefit of being representative of a larger population or generalizable of a larger population. So samples are selected in accord with probability theory. These are used in very large-scale surveys. This is not a one-man job. These are done with very, very, very large-scale stuff that you're definitely going to need a lot of people working on it. They're very expensive to do as well. So I'm not expecting you to do any sort of probability sample for your final project. So a sample of individuals from a population must contain the same variations that exist in the population. Okay, so again, it's going to be representative. The sample has the same characteristics of the population from which it was selected. So these are, not just one demographic, but they're often chosen on many, 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 many different things. If we think about the census and the sampling used for that, general social survey, these very, very large scale studies, they use the probability samples. So samples don't need to be representative in all respects, but only those that are relevant to the research at hand. So a very, very important feature of probability samples is that all members of the population have an equal chance of being selected to be part of a sample. So you might be thinking, how do, we figure out who, make sure that everyone has a chance of being part of the sample? Well, we use a sampling frame. Sorry, I'm just going to go back to this one. No. Okay, so a sampling frame is a list of units composing a population from which a sample is selected. So you need to have a list of every possible unit that is in that population. So for example, if the population, again, is Texas Tech students, you need to have a list of every single student that is currently enrolled in Texas Tech, and that is going to be your sampling frame. So if you have a sampling frame, you can use a probability sample. If you do not have a sampling frame, then you're going to have to use one of the non-probability methods. Okay, so sampling frames are never perfect. For example, our list of students at TTU, maybe that list was only updated the last semester and a bunch of students have graduated or, dropped out of school. The Lubbock phone book, another one, problems with that. Well, unlisted numbers, people that don't have a phone. So your sampling frame is, we try to make it as accurate as possible, but it's sometimes going to have some issues. Okay. So some advantages of probability sample, again, representativeness, biases can be avoided. We can also estimate the accuracy and representativeness of the sample. Disadvantage, again, is difficult. It takes a very long time and it's very, very expensive to do. Okay, so our first type of probability sample is our simple random sample. This is units composing a population are given numbers, and a set of numbers are randomly generated. So basically, you list every single student in Texas Tech from 1 to 38,000 now, 40,000 around, and then you use a random number generator, which is available online, and just generate a bunch of random numbers. So that is how you get a simple random sample. It's, the easiest one to use, but it's not always going to be the most accurate. Okay, so systematic sampling, again, is another type of probability sample. You have to list every single unit that is in that population. So Texas Tech students, again, 1 to 38,000. And then you decide to pick every 12th student to be part of that sample. So again, it might be a little bit more accurate than simple random sampling. I don't necessarily believe that's the case. I think it's just about as accurate, but it's easier to do than some of the more, more complex probability samples. Stratified sample. So this one is going to be a little bit more accurate than the last two. This is when you group the units composing a population into homogeneous groups before sampling. So again, more accurate than simple random and systematic sampling. The stratification is a modification to simple random and systematic sampling methods. So what you do, for example, maybe our Texas Tech students, we want to group them by major. So we're going to, group those people, those units by different majors, and then do the simple random sampling after that, or the systematic sampling after that. This is going to ensure that it's going to be more likely that we're going to get people from every, from most of the different, the characteristics that we're looking for, in this case, major. But if you see at the bottom, there's those kind of dark blue people, they didn't get chosen. So it's not always the greatest. It's better than simple random and systematic sampling, but there are, better ways of doing this. All right, multi-stage cluster sampling. So this is for very, very large scale, studies. So Natural groups are sampled initially, with the members of each selected group being subsampled after. So maybe you want to, do a study on Americans. Maybe you decide to pick, 100 cities in America. And then out of those 100 cities, you're going to make a list of city blocks, sample them, and then make a list of addresses, and then sample that. So it's, again, multi-stage, meaning we're doing multiple samples to get at our sample. It's used when it's not practical or possible to create a list of all elements. It's highly efficient, but it's also less accurate. So again, we use this on, if we're doing a very, very large scale study, say, people in Texas. We don't have a list of everybody in Texas, but we can, make a list of all the cities and towns and then sample from that list and then sample from city blocks and then sample from addresses. Okay. So we're going to talk a little bit about sampling distributions now. So let's imagine a population of only 10 people with differing amounts of the money in their pocket ranging from 0 to 9. So this is just to sort of demonstrate if your sample is 1, you're really going to not have a very good idea of what your actual mean or the middle value is of what you're looking for. In this case, it's dollars, a dollar amount in the individual's pocket. So if we pick 10 different samples of one person, our estimates would be, the mean of ranges across all the boards. So, we would get at the mean, but that's, it's difficult to do. So, after increasing our sample size to 2, the possible samples are going to cluster around the mean just a little bit better. So 0 and 9 are not going to be included. So again, it's going to be closer to the mean. It's still, going to be, we're not going to really be able to see what the mean is using a sample of 2. So as we increase the sample size, that possible value clusters around the mean even more. So the chance of extremely inaccurate estimates is reduced at the two ends of distribution, and it's going to be more likely that it's going to be close to the true mean. So this is just to show that, as our sample gets larger, it's going to be likely that the value we pick is going to cluster around the true mean. That doesn't mean that we need samples of 1 million people. There's, different, statistical analyses that we can do to figure out exactly what sample size we need. But generally, larger samples are going to be more accurate than smaller samples. Okay, so shifting to more realistic example, let's assume that we want to sample student attitudes concerning a proposed conduct code. Let's assume that 50% disapproves, but the researcher doesn't know that. So our mean here is 50 from 0 to 100. So if we have a large student body, we can select different samples with who's available of a substantial size. We wouldn't necessarily say that these samples are going to be perfect every single time, but if we look at all these samples together, we should be able to come reasonably close. So for our mean of 50, if we pick 3 different samples, they're not going to be exact, but they're going to cluster around that mean of 50, pretty close. So again, if we were to select a large number of good samples, we would expect them to cluster around the true value, but given such samples, a few would still fall far from the mark. So again, even though we pick those samples, there's still going to be a few samples out there that's going to be, off. Okay, finally, the ethics of sampling. Probability sampling always carries a risk of error, and researchers must inform readers of any errors that might make results misleading. When non-probability sampling methods are used, the researcher really needs to let the reader know how their sample was chosen and the biases that it might have. So if not, they might, mislead readers into confusing, what's typical in the population. So for example, if you're, researching Texas Tech students and you pick 20 students that you're friends with, that's probably going to be biased because, those students that you're friends with are probably going to have something in common with you. So again, you always have to talk about the sample, how you made your sample, your sampling frame if you have one for a probability sample. And if a non-probability sample is used, you must, state how you found these individuals to be part of your study or, groups or whoever. and the biases that might be there.